Guys, lesson 15, solving systems of equations of substitution. This is going to incorporate a lot of stuff that we've learned in this course. The learning objective is quite simple. You're going to learn how to solve systems of equations by substitution. And we've already substituted in this course. There's at one point in the course we were given a value to substitute in for x. This is a lot like that, but instead of substituting a single number, we're going to substitute an equation or an expression for y. There's two things that you got to know. First, you got to know how to substitute something in place of a variable, which I think you know how to do that. And you also need to know how to solve an equation for y. And we've been solving for y for 3 or 4 lessons now, so there shouldn't be anything new here other than the application towards a new set of problems. So just a reminder how to substitute a value in place of a variable. So, let's say if we have no x is equal to 10. So what's the value of 4x plus 7x plus 3x when x is 10? Can you remember how to do this problem? What should you do? Right, you should combine like terms. So you got your 3 like terms here, you'll combine them, and whatever that number is, you'll plug in 10 for x, and that's going to give you your answer. I'll let you spend a moment to figure this out on your own. Pause the video if you need to. So to solve this, you do 7 plus 3, which is 10x. 10x plus 4x gives you 14x, which we have here. We know x is equal to 10, so we wrote down 14 times 10. Well, 14 times 10 is 140. If you can do that, you can do the algebra that's in this lesson. So now we're just going to substitute an expression for a variable. So we're given this, y is equal to 2x plus 27. We're told that x is negative 4y. The only difference is just how this looks. It just looks different. Looks different, but it acts the same. Looks different, but it acts the same. So you're going to do 2 in place of x, negative 4y plus 27. That's all equal to y. So let's see if you can solve this. You want to pause the video, and I'll be back in a moment to help you out. Let's see what you did here. So we had 2, and instead of x, we're saying x is now negative 4y. So what's 2 times negative 4? That's right, it's negative 8y. So now we have y is equal to negative 8 times y plus 27, which we see here that's in a little bit cleaner format. So when you're given an equation, and forget about everything we've done now, just think about this as a whole new problem. We're starting over with an equation, y minus 8y is equal to 27. What do you do to solve this? That's right, you add 8y to both sides. You want to get a number. It's a question mark. Make my question mark better. Question mark is equal to 27. Can you solve this? Let's see what you can do. Pause the video if you need to. Well, if you did what we did earlier in the year, you substituted negative 4 in here. 2 times negative 4 gave us the negative 8y. So we had y is equal to negative 8y plus 27. So we're going to add 8y to both sides, which is what we're doing here. Y plus 8y is 9y, which is how we got this 9y. So 9 times y is equal to 27. What's the inverse operation of multiplication? That's right, it's division. So we're dividing both sides by 9. 9 divided by 9 is just 1, which is when we have 1y. 27 divided by 9 is 3. So we know y is equal to 3. For fun, we can plug that back in. And we would get the same thing. Now we've got something a little bit more complicated, but it's going to work just the same. Here we still have an expression. So now we got y is equal to 2, but instead of x, we're writing y minus 7 plus 27, and we want to solve for y. Remember, a long time ago, we would distribute before solving an equation. We're going to use that skill again here. We're going to distribute the 2 and then solve for y. So when we distribute this 2, you have 2y minus 14 plus 27. That's equal to y. So we have y equals 2 times y minus 14 plus 27. So to solve this for y, you may want to pause the video. Try to work on your own first. You should have. Hopefully you got this figured out on your own, but if not, I'm still here to help. So we distributed our 2 at the beginning. So 2 times y is 2y. A positive times a negative is a negative. 2 times 7 is 14. We didn't touch 27, so we bring it down. 27 minus 14 is 13, which is where we got the 13. So now we want to move our y from one side of the equation to the other. So we're subtracting 2y from both sides. So we have that minus 2y. Well, 2 minus 2 is nothing. Since we didn't touch the 13, we bring that on down. And it's a positive 13. Negative 2 plus 1 is negative 1, which is why we have this negative sign here. Negative y is equal to a positive 13. And remember, that's a negative 1y, which is why we divide both sides by negative 1. So we're divided by negative 1 here and here. A positive divided by a negative is a negative. So our answer is y is equal to negative 13. So we just substituted an expression for a variable. And that's what we're going to be doing in just a minute when we solve these systems of equations for a variable. So there's nothing really super hard here. We're just solving equations. We're just doing more than one equation and one problem. But if you break it down and do it step by step, so you're just doing one equation at a time, super simple. So now we've got this system of equations. We know that and we have y is equal to 2 different things. Well, we know y is equal to 7 times x plus 4. And we know that value is the same thing as negative 4x minus 7. One thing that confuses people when they first start learning this is they're like, well, what do I set to be equal to, itself or equal to equal? Well, you set your equations or expressions up so variables are equal to like variables. So you could say, well, y is equal to y, which that's a true statement. We know that's a true statement from earlier in the year. It's a reflexive property, but there's no math to do there. We can't get a single number. There's infinite solutions. But if we did 7x plus 4 is equal to negative 4x minus 7, we now have an equation with variables on both sides. We got variables on both sides. So when you look at this whole problem here, it's easy to get, intimidated. It's daunting, but when you just look at this little problem here, it's a little bitty baby problem. It's easy. We've done these problems before. So let's just look at this one little problem. It's one problem. We're putting the rest of our work out of our mind. How did you solve this earlier in our course? That's right, we isolated the variable. And if you're like me, you always like to move the smallest variable. Negative 4x is the smallest variable. What do I do to get rid of a negative 4x? Working a simple equation with variables on both sides. Earlier in this course, we had problems like this, and we worked to isolate the variables, right? And we always like to start with the smallest variable. So I'm going to move this negative 4x by adding 4x to both sides. But negative 4 plus 4 is nothing. The only thing here that I hadn't touched is that negative 7. So I'm bringing it down. So we got negative 7. And then 4 plus 7 is 11. So we got 11 times x. We have 7 x's. 1, 2, 3, 4, 5, 6, 7. And we have 4 more. 1, 2, 3, 4. If you counted them all up, we'd still have 11. We didn't touch that plus 4. We're bringing it down. So now we want to move our constant, this 4, to the left side. How do we move one number to the other side of an equation? That's right, we use inverse operation. So if we're adding 4, we got to subtract 4. Well, plus 4 minus 4 is nothing, so we're left with 11x. So if you have negative 7 and you subtract negative 4, you're at negative 11 on the number line. Finally, we've got 11 times x is equal to negative 11. What's the inverse operation of multiplication? That's right, it's division. So we're going to divide both sides by 11. What's any value divided by itself? That's right, it's 1. And what's this 11 here is positive. That's a negative. What happens when you divide a negative by a positive? Perfect. It becomes a negative 1. So we know x is equal to negative 1. Came up with the fact that x is equal to negative 1. So now we just need to figure out what goes in our y spot of our relation. So to do that, we just substitute negative 1 for x. So here you'd have 7 times negative 1 plus 4. Here you'd have negative 4 times negative y minus 7. So if you want, you can pause the video and try that for yourself, see what you come up with. So here we're going to do 7 times negative 1 plus 4. Well, 7 times negative 1 is 3. Not 3. Just kidding, little mouth joke. 7 times negative 1 is negative 7. Negative 7 plus 4 is negative 3. So we're thinking that the intersection may be at negative 1, negative 3 because we substituted negative 1 from our previous work into this equation. Let's look at the other equation that was given to us. So we had negative 4 times negative 1 minus 7. So negative times a negative is a positive. 4 times 1 is 4. 4 minus 7 is negative 3. So once again, we got negative 1, negative 3. So that's the solution to our first system that we've done by substitution is negative 1, negative 3. This one, notice what's different. And I'll let you think about it before I tell you what's different. Yeah, what's different is these equations aren't solved for y, so we need to solve for y. So this first one here, you want to subtract x from both sides. That'll give you something. And then here, you want to subtract both sides by 3x and divide by y. I'm not going to give you those answers just yet. Pause the video, try to work it out on your own, and when you come back, I'll show you what to do step by step. So we're going to solve this first equation for y. And once again, what do? That's right, we subtract x from both sides. So now we have this equation, y is equal to x plus 1. So we're going to hang on to this equation for a little while, and we'll come back to it. If it's on your paper, I'd circle it, highlight it. Next is we're going to solve this equation for y. So remember what to do here? That's right, we're subtracting 3x from both sides. After we subtract 3x from both sides, you'll have something that looks like 3y minus 3x plus 3. What comes next? What do you think? Division, that's right. So here, we're dividing everything by 3. 3 divided by 3 gives us 1y. We don't write that 1 down. It's understood. Negative divided by positive is a negative, so we got that taken care of. 3 divided by 3 is 1, so we have negative x, or negative 1x if we wanted to be accurate. And anything divided by itself is 1. 3 divided by 3 is 1. So now we have our equation, negative x plus 1. And if you remember, the other equation was x plus 1. Now we're going to set both of these expressions equal to each other, which is step 3. And this is something that we didn't have any problem with, because really all this is, it's an equation with a variable on both sides. So we're going to use inverse operations to move the smallest variable and then divide by the variable coefficient, and that's it, we're done. So to kind of prime you, we're going to add x to both sides and then move the constants and then divide by the x coefficient. You may want to pause the video while you do that on your own. So here's the work. We added x to both sides. Negative x plus x gives us nothing on the right-hand side. But on the left-hand side, x plus x gives us 2x. So now we have this plus 1, 2x plus 1. So to move this 1, we got to subtract it. So 1 minus 1 is 0. It just leaves us 2x on the left side. 1 minus 1 is 0. Then we divided both sides by 2. 0 divided by 2 is just 0. So we know x is equal to 0. So moving on to step 4, we're going to plug this back into one of our original equations. And what we're plugging back, in case you forgot, is x is equal to 0. So instead of x, what am I going to write? I'm going to write 0 plus y is equal to 1. Then we're going to solve for y. Well, 0 plus anything is just anything, right? So 0 plus y is just y. And then we're left with y is equal to 1. Now we've got the other equation we hadn't dealt with. So we're going to plug in 0. So you have 3 times 0 plus 3y is equal to 3. Can you solve this without any help? I bet you can. I bet most of you guys did 3 times 0 plus 3y, which gave you 3y on the left-hand side. And then we had 3y is equal to 3. Since 3 times y, the inverse operation is multiplication. I'm sorry, the inverse of multiplication is division. We divide both sides by 3, so we have y is equal to 1. Final step is just to double check our work. So remember, we said our intersection was 0, 1. We'll go ahead and write it down. And we're going to just plug them into both equations. If 0, 1 is the actual solution, when we plug those values in for x and y, we'll get our original answer. So here, x plus y is equal to 1. You plug in 0 for x and 1 for y, and do the math. 0 plus 1 is 1. 1 is equal to 1. That is a true statement. Our work is correct. If your work is incorrect at that point, you got to go back and fix it. It's not a big deal. You know, the thing about learning math is you make a lot of mistakes in problems like this. Even though they're pretty simple, there's lots of steps, and it's just easy to make a mistake. Now we're going to plug in 0 and 1 into our other equation. So 3 times 0, once again, is 0. 3 times 1 is 3. 0 plus 3 is 3. So we have 2 true statements. So our work there, thankfully, is correct. If you ever get to that point in a problem and your work is incorrect, don't freak out. It's not a big deal. It doesn't mean you're not intelligent. It just means you're human and you made a little mistake, and just go back and fix it. So to recap, we've been working with systems of equations. So we can do 2 equations on a grid. This lesson, we didn't graph them, but we used algebra to manipulate them. What we did is we set both equations equal to y, and then we set whatever we came up with expression-wise equal to each other. So we solved both equations for y. We set the x expressions equal to each other. We solved for x, which is just a variable on both sides problem. We took that x value and we plug it back into the original equations for x. At that point, we solved for y with the new number. We checked the solutions by substituting the values of both variables we found into both original equations to make sure they satisfy both equations. And by satisfying both equations, we just wanted to make sure they turned into true statements. This should get you through your online practice. This should get you through the mastery problems. And this should get you through your quiz. If you have any questions, just reach out.